we are going to discuss the cybersecurity project topic, that is digital steganography, presented by following members, starting with what is steganography. Steganography is a technique of hiding confidential information within any media. So simply, it is a practice of hiding secret message inside of something that is not secret. The process of detection of steganography is called a stegna analysis. In this article, we have tried to explain the different approaches towards implementation of steganography using multimedia files. Following are the problem statements that we come across while design and implementation of steganography. First, how can we send a message secretly to the destination? Using steganography, information can be hidden in carrier such as image, text file, audio file, videos, and data transmission. In this study, we propose a new framework of an image steganography system to hide a digital text of a secret message. Be continued by my other member.
So now for the literature review. For the literature review, we had a look on the literature, that is the fractional Fourier transform, which was proposed in the year 2013 by Sony A, J&J, and Roshan R. This investigated on a generalization of classical Fourier transform introduced years ago in mathematics literature. The enhanced computation of fractional Fourier transform, the discrete version of FRFT, came into existence. This study illustrates the advantage of discrete fractional Fourier transform, that is DFRFT, as compared to other transforms for steganography in image processing. The result shows same PSNR in both domain, that is in time and frequency, but DFRFT gives an advantage of additional stego key. So the order parameter of this transform is nothing but implemented a various of a plain LSB, that is least significant bit algorithm. The stego image quality has been improved by using bit inverse technique. LSB method improving the PSNR of stego image through storing the bits patterns for which LSBs are inverted image may be obtained correctly. So now let's move on to the proposed methodology. The proposed methodology is nothing but based on the LSB technique. With the help of this technique, the data hiding is very impressive as it uses a simple algorithm and it can convert any image into a steganographic image. So let's consider first pixel of the image. That is nothing but the pixels from the red, green, and blue versions, that is as shown in the figure. So this process is very huge because converting every image pixel value into its binary and after manipulating again converting it into decimal value takes a lot of process power and time. So to withstand the problem, instead of manipulating every LSB of byte, we have to convert the value into either even or odd. For example, let's consider if we have to change LSB of the red pixel from 0 to 1 or 1 to 0, we will simply convert the pixel value from odd to even by adding 1 or by subtracting 0 and vice versa. Hence, it will automatically save the processing power as well as the time. The further will be explained by my teammate.
Results and user scope. For testing purposes, we have to use a database of 900 grayscale images of natural scenes. All images were obtained using a digital camera and originally stored as JPEG images. The same database of 70 images was used for evaluation of the performance of our detection method. Among the 70 test images, 24 of them were processed using audio with message sizes ranging from the maximal capacity to 0 because all test images were originally stored in the JPEG format. Scope of the project. The scope of the project is to limit unauthorized access and provide better security during message transmission. To meet the requirements, I use a simple and basic approach of steganography. In this project, the proposed approach finds the suitable algorithm for embedding the data in an image using steganography, which provides the better security pattern for sending messages through a network. For practically implementing the function of the discussed algorithms, Microsoft.NET framework is used. Next slide will be handled by the next member.
I will show you the live demo of our project. Here we will execute the Python file. This window get open. First we will click on encode, then we will click on intake image. Here we have to enter the path of the image. So for example, we have taken here sunflower image. So we will copy this path and we will enter it here, and then we will enter the image name, which is sunflower.png. Here we will enter the path where we will save encrypted image. So we will save it in the exe file. So here we will enter the name, copy the path, and we will paste it here. Here we will write the name of the image. So we can take any image, let it be abcd dot png, and here we will write the message which we want to encrypt behind the image. So the message is secure, or we can encrypt it, and we will run this. Once we will run this, we have see this is the algorithm. Message is converted into ones and zeros. Now let's check. See, this we have got abcd. This is the encrypted image. Nothing has been changed, and this is the original image. Both are same. So now we will decode this. So we will press on decode written. Here we will enter the file where the abcd image is saved. We will go on exe. We will copy the path and we will paste it here. The name of the image was abcd of png, and we will run this. This is the message which we have given. The message is encrypted, and when we will look in the folder, the exe file is also been made. That's all from our team members and from me. Thank you.